So my title is Use Cases for Digital Transformation Through Location Tracking. So who is Ubisense? Ubisense is a British company that was founded in 2002 in Cambridge, and is our mission to use location tracking and identification and enable all sorts of processes. So here you see the timeline and some of the logos of customers we acquired along the way. It had already been said that there are a wide variety of location technologies like RFID and GPS, of course, you all know. But Ubisense specializes first in ultra-wideband. That is a part of the electromagnetic spectrum above about 4 gigahertz, and also has a software solution that combines enables to integrate all of the mentioned different technologies. So Ubisense wants to track real-time location, movement, and interaction of people, devices, and products in all kinds of manual processes. And this is especially relevant for industry. So many presentations have tackled the thing, digital twin, what is that? So we want to map the real world into a digital world, and for that we need some kind of software platform. This is the software part of what we are presenting to you. This goes by the name of Smart Space. By that we create a digital twin of your environment and your processes, so that you can program space into some organization of real-world events and define processes. You have just seen in Thomas' presentation how BMW is using this for controlling their own production processes. From what I said, you can infer that we have these two things. That one is the hardware that goes by the name of Dimension 4, that comprises sensors. You see a sensor down here. This is a kind of an antenna that is receiving signals, and the signals are sent out by these small things. We call them tags. These are emitting ultra-wideband signals, and in this way, because the sensors track the time difference sent out, different sensors see the tags under different angles and also measure the time difference in which the signal hits the sensor. It can infer where the tag sits, and the tag is a proxy for a person, for a device, for something that needs to be tracked and located. And because we use these two measurements, both angle of arrival and time difference of arrival, this is our unique selling point in the market. We are very reliable, and we are used in a Six Sigma mode. That means 4 defects in a million defects. And this is what is needed in a high-value production chain, like an assembly line at the automotive manufacturer. We also have a very long battery lifetime, up to 15 years, and this enables 24/7 operation over many years. On the other hand, we have the Smart Space software that integrates all of the sensor readings and makes it possible to control the installation, to program via an API, to connect to your backend. And there are a lot of software development hours baked into the software, which we regard as best of breed here. Here is a picture showing the modular architecture of our software. It ingests the raw data coming not only from ultra-wideband, but also from all other kinds of systems. I will come to that in the next slide as well. Then there is a core software, and then a module of different software packages enabling you to do different things, like define business rules, define a visibility of a process, where it is which part in the plant, do reporting. All kinds of reportings are able to be done. You can connect to your backend systems. Devices can connect And there is something like operational support and monitoring, which you need also. On top of that, you can build your own applications. And this is something that, for instance, BMW has done with their IPSI, the International Production System. So here you see there are a variety of technologies, all of which can be integrated into our smart space. Ultra-wideband RTLS, this is our own hardware, but equally well, we integrate with GPS, with barcode scanning, with RFID, with Bluetooth low energy, and also with vision systems. All of these systems have their advantages and disadvantages, so you choose the right tool for the job in regard of your accuracy requirements and the business value and cost. As I said, you can integrate into your backend systems via APIs. Also, we send telegrams for TCP/IP, and you can use that as well. So you can connect to your SAP system or your MES system. Now I come to the use cases. I will show you 5 use cases that pertain to different sectors of industries, automotive and commercial vehicles, aerospace, and logistics. But you see, there have also already been other use cases as well, even entertainment, health sciences, and electronics. So the first use case is tool control. What do we mean by that? You see here an automotive assembly line, and there is a tag on both the bonnet of the car. These are the brown arrows here. So this tag is sending its signals, and these signals are received by our sensors or antennas. And there is another tag on the tool. This is a wireless tool for fastening bolts, and this is a worker who has this tool in its hand. So what does tool control do? Tool control ensures that the tool is only enabled at the right vehicle, and you cannot use the tool with the wrong torque, for instance, or wrong configuration at another car that it doesn't belong to. Otherwise, you would have a fault. So you save both on manual error and on efficiency, because otherwise you would have to barcode scan before you use the tool. And now you save some time, and you can produce more cars in the same time. And this leads to measurable efficiencies and measurable cost improvements. This is in production at some of the most of the largest automotive manufacturers, not only BMW, but also Daimler, Volkswagen, Honda, and many others. The next use case is production logistics. Because of the many variants of modern cars, not a single car is exactly equal to another one, even if you produce 1,000 cars a day. And you have to ensure that the right parts are at the assembly line at the right time. Otherwise, if you run out of parts, you have to stop the production line, and you will lose some units. You cannot produce as many units as you have planned, and this is wasteful. So you need to ensure and track where are your things, where are your logistics trains. And these logistics trains, again, you see one train here with several carts behind it. They are tracked from an emitting tag, and the tag sends out these signals. The signals are received by our installation here to both sides. So at each time, in real time, you know where is your assembly parts, and you can direct them to the right location at the assembly line. This is also in production at, for instance, BMW or Mitsubishi Fuso. The third use case is yard management. Yard management is used, for instance, for big commercial vehicle manufacturers such as Claas or John Deere, who have many tractors who are waiting in the yard. They are not yet ready because some must undergo additional quality inspections or some rework if something has not been, if the workers have not been able to put it there right first time. And these yards can be very extensive. And you need to know where is the car and where should it go next, what needs to be done. And so at the right-hand side, you see a map of your yard, and you can pinpoint single cars. You can also search for them. And it says it's awaiting inspection. And it has been sitting there 9 days. So you can use also the data and looking, is this waste? This is work in progress, but why is it sitting there for so long? And or where is the customer wants his tractor, what needs to be done? So this can save efficiency and by enabling more tight processes here. Here we not only use ultra-wideband, this is used indoors, but you also use GPS outside. So we have tags that combine these two technologies. And then again, there is smart space behind it where you configure both the maps, the rules, and processes. You get automatic notifications if something has been forgotten or is sitting in some place for too long. A similar use case is transit yard management. This is used, for instance, for companies that use buses for transportation. And the buses are parked in such a way at the end of the shift, of the daily shift overnight, that it's easy to pull them out of the yard again the next morning. So the bus that goes first out should be there sitting not somewhere in the inside, but somewhere at the outside, so it can drive away. It doesn't need any reshuffling. And you also can check for instance, do the buses need some update or some cleaning, some charging, some maintenance? All of this can be tracked live, real time, and you again have a map and you see which buses are green, which are red, and something is amiss there and you have to look at it. So this is used all over the world, especially in cities in the US and in Switzerland. Then we have process monitoring. This is used for the so-called offline area. This is the part of a production manufacturer plant where the cars can go by themselves. So they have wheels and left the assembly line, but still they have to undergo some quality checks or some rework. And here we can not only find the cars, such as in yard management, but we can track the complete history where the car goes and where it has been before. We have these spaghetti diagrams, and you can use this information to plan or replan and optimize your processes. And you also see if the car is sitting there too long and maybe there's something amiss, we should somehow change the processes so that you have less waste. So these were the 5 use cases I wanted to bring to your attention. And the last slide shows some of the logos of our many customers worldwide. And I'm glad to take questions to both this talk and as far as I can answer them also to the talk before, because I think Thomas might already have left because he had another date. But I'm glad to answer any questions you might have. Thank you very much for your attention.